In today's lecture, we'll discuss about the security aspects of cloud computing. Let us first see the definition of cloud security. So, cloud security involves procedures and technology that secure cloud computing environment against both external and internal cybersecurity threats. So, cloud computing has enormous potential as it provides the following advantages to the customer. Reduced capital cost, as it eliminates the capital expenditure to set up the IT infrastructure completely. Divest from infrastructure management. This is because the users do not have now to manage any infrastructure. It is the responsibility of the cloud provider. Focus on core competencies. So therefore, users can now focus more on their core competencies instead of managing IT infrastructure. Cloud computing also provides agility to the user's business, as organizations can move faster since they don't have to purchase and provision hardware, and everything is software defined. So by software defined, we mean that everything can be obtained at a click through a console. It also provides resilience to the user's data and the services, as it reduces the downtime because of the inherent elasticity and other cloud characteristics, like for example, location independence. Further, it also aligns IT with business strategies and needs very quickly. However, the major concern of the user to migrate to cloud is about the security. So customer concerns are about the risk of cloud computing if not properly secured, and the loss of direct control over the system for which they are nonetheless accountable. So if you see, the cloud security problems are coming from loss of control and lack of trust. So their general concerns are data or processes are running on third parties infrastructure. Users are also concerned about the availability of their own data. There can be an unauthorized access to the user's data. The process or the data can be intercepted by some other party or client of the cloud. Then missing of critical processor data such as banking, defense, and even student related data. So that is sensitive data. So if users have sensitive data, they are bothered about the loss of this sensitive data if stored in cloud. So these are some of the issues which are of concern to the cloud user before they can make a decision to migrate to a cloud. So in order to address such issues, to aid both cloud customer and cloud provider, CSA, that is Cloud Security Alliance, developed security guidance for critical areas in cloud computing. They designed the first version of best practices by Cloud Security Alliance in 2009, and now version 4 is followed. So cloud security and security management best practices are designed to prevent unauthorized access and to keep data and application in the cloud secure from current and emerging cybersecurity threats. By unauthorized access, we mean that the data should be accessible only to the intended user. So cloud security in cloud computing prevents unauthorized entry in the cloud, unauthorized entry of malicious user in the cloud, and it secures the services, data, and applications which are stored in cloud. So in this lecture, we'll first discuss about network security, computer and network security in general, and then in coming lectures, we'll discuss about the security from the viewpoint of cloud computing. This is because the cloud security is a subdomain of computer security, network security, and more broadly, information security. So let us look at this. In general, security has three main components. confidentiality, integrity, and availability. So let us define these terms first. So confidentiality refers to data and resources are hidden. So confidentiality is the concealment of information or resources. It can be done through techniques like cryptography and enciphered data. So confidentiality is a set of rules that limit the access to the information. That means only the intended users or the authorized users can access the information or the data. Next is integrity. So integrity is the assurance that the information is trustworthy and accurate. So it deals with data integrity and authentication. So integrity refers to the trustworthiness of data or resources, and it is usually phrased in terms of preventing improper or unauthorized change in data. Next, availability. Availability deals with access to data, processes, or resources. So availability is the ability to use the information or resources as and when desired. So availability basically is a guarantee to reliable access to the information by authorized people. So let us see the classifications of attacks. So basically all the attacks on computers, networks, or information systems are to compromise the component of security. Examples are denial of service, DOS attack, or distributed denial of service, DDoS attacks. Such attacks are denial of resources to the legitimate users. We'll look at these in little more detail in coming few slides. First, let us see what are the types of attacks on information security. So one classification can be either the attack is a web-based attack, that is through internet, or it is a system-based attack. Web-based attack. First, DOS, denial of service. It's a crucial attack that destroys fully or partially victim's network or the entire IT infrastructure to make it unavailable to the legitimate user. So in denial of service attack, it occurs when the legitimate users are unable to access the information system, device, or other network resource due to the action of malicious user. Next is DDoS. DDoS is distributed denial of service. So in this attack, the attacker uses multiple compromised systems to target a single DOS attack targeted system. The DDoS attack also leverages botnets. So what are botnets? Botnets are a number of internet connected devices, each of which is infected by a malicious code. That means each of these devices is infected by a malware that allows the malicious user to control them. So in DDoS attack, it basically disrupts normal traffic of the targeted server network by overwhelming the target and its surrounding infrastructure with flood of internet traffic. Next, phishing. So it is a type of attack which attempts to steal sensitive information like user login credentials, like username, that is username and password, credit card numbers, and it occurs when the attacker is masquerading as a trustworthy entity in electronic communication. For example, if the user wants to steal the login credentials of, let's say, a Gmail account, so what they will do is they will create a page or a web page which is absolutely identical to the Gmail web page. And when the user enters their credentials into that web page, which is not actually the Gmail login web page, so that sensitive information will then be available to the attackers. Next, man in middle attack. It allows the attacker to intercept the connection between client and server and act like a bridge between them. So, due to this, an attacker will be able to read, insert, or modify the data in the intercepted connection. So, in this, the attacker sits between the client and the server, and is all the data which is going from client to server or vice versa goes through the attacker. So, they have the access to the complete data, which they can also modify. DNS spoofing. So DNS spoofing is about compromising a computer by corrupting domain name system data and then introducing it in the resolver's cache. This causes name server to return an incorrect IP address. So basically it means redirecting the online traffic to a fraudulent website rather than the one that it is intended for. Next, IP spoofing. It is a process of injecting packets in the internet using false source address, and it is one of the ways to masquerade as another user. So that means the attacker, what will it do? It will use the IP address of a particular source, a false source address, and it will inject packets in the internet with that IP address. Finally, the compromised key. So basically, so key will be used in cryptography to encrypt or decrypt the data. So in this, an attacker gains unauthorized access to a secured communication using a compromised key. So in this, if the attacker has the key, then it can use the key to access a secured transmission. And source and destination are not aware about this. Let us also look at system-based attacks. First, virus. So it is a malicious software program, but it is not self-executable. However, it spreads throughout the computer files without the knowledge of a user. Malware. So malware attack is one of the most severe cyber attacks that is specially designed to destroy or gain unauthorized access over a targeted computer system. Worm. It enters the computers when infected by network application and it is executed by the user. It replicates and infect other computers. Trojan horse. It is again a malicious program and it causes unexpected changes to computer settings and unusual activity even when the computer is idle. Backdoor. So backdoor is a method that bypasses the normal authentication process. So using backdoor, what is the attacker can get around the normal security measures to gain high level access, root access. Bots. A bot is basically an automated process that interacts with other network services. So some bot programs run automatically while others only execute command when they receive specific input. So bots are basically devices which are infected by malicious codes. Let us see another classification of attack. It is active attack and passive attack. So what happens in the active attack? In active attack, the attacker will have the access to the data and they might even modify that data. But in passive attack, it's a silent eavesdropping on the data. So attacker will simply have access to the data, but it is not modifying the data. So let us look at these in detail. Active attack. An active attack attempts to alter system resources or either affect their operation. It involves some modification of the data stream or creation of false alarm. It can be subdivided or categorized. It can be subdivided into 4 categories. First, masquerade. Masquerade basically means to disguise, to impersonate. So the attacker uses false identity to access otherwise unauthorized information legitimately. So in this, the attacker poses as somebody else and will access the data which it is otherwise not allowed to access. Next is modification of message. So this means that some portion of the message is altered or the message is delayed or to produce an unauthorized effect. Next is replay attack. It is a form of network attack in which valid data transmission is fraudulently repeated or delayed. This is carried out either by originator or by an adversary who intercepts the data and retransmits it. So in this, the data can be either repeatedly sent or it can be delayed. So which might affect the processes which are being carried out by the destination. Finally, a denial of service attack. So we have already looked into it. So basically it is an attack which is meant to shut down a particular network or server or a particular process by making it inaccessible to the intended users. So, and this is accomplished by flooding the target with traffic or sending it information that triggers a crash. In both the instances, DOS attack deprives legitimate users of the service or resources they may expect. Let us have a look at the passive attacks. So passive attacks are in nature of eavesdropping or on monitoring of transmission. So it will not change the attackers in this passive attacks do not change any data. They only gain access to the data. The goal of the opponent is to obtain the information that is being transmitted, and they are very, very difficult to detect because of that. So these are of two types: traffic analysis and release of message content. So traffic analysis. So in this, the attacker will simply analyze the traffic pattern. By analyzing the traffic pattern also and the location from where it is being sent, the source, destination, it can have a lot of information. So even if the information is masked or encrypted, the attacker, by analyzing the traffic, gets a lot of information such as pattern of these messages, the location and identity of communicating hosts, and the frequency and length of the messages being exchanged. So here the attacker will simply analyze the pattern of the traffic. Second is release of message content. In this, what will attacker do? It will monitor an unprotected communication medium. Like for example, unencrypted email or a telephone call and intercept it for sensitive information. So wherever the communication medium is unprotected, there the attacker will start monitoring, and then it can have access to the emails or telephone calls. Emails only if they are unencrypted. If they are encrypted, then it will not make any sense to a passive attacker. Threat. So let us see what is a threat. A potential cause of an incident that may result in harm of system and organization. Let us see the definition of threat, which is given by NIST. Any circumstance or event with the potential to adversely impact organizational operation, including mission, function, image, or reputation, organizational asset, or individuals through an information system via unauthorized access, destruction, disclosure, modification of information, and or denial of service. Also, the potential for a threat source to successfully exploit a particular information system's vulnerability. So this definition says that threat is any circumstance or event that can potentially harm the organization's operations or assets or individuals due to unauthorized access or destruction or disclosure or modification of the information, or maybe denial of service due to any of these reasons. For example, if there is a new technology which is launched and the users start using that new technology, then there might be some loopholes which are still there, which attackers can use, and these loopholes then are a threat to the user because that technology is still vulnerable and is not very robust against the threats. Let us see few terms before looking at the classification of threats. So threat, an object, person, or any other entity that represents a constant danger to an asset. Threat agent is the specific object or person who poses such a danger. For example, DDoS attacks are a threat. If a hacker carries out DDoS attack, then that hacker is a threat agent. Vulnerability, weakness or fault that can lead to an exposure. For example, if a new technology is launched and there are some loopholes in that technology, so that is the weakness or the fault of that technology which can lead to an exposure. That means the attackers can exploit that particular loophole to attack the user. Risk. So how is the risk defined? It refers to the calculated assessment of potential threat to an organization's security and vulnerabilities within its network and information system. So risk is equal to threat into the likelihood, that is the probability, and the impact that it causes. So there are three factors which decide the risk, that is the threat, the likelihood of that threat, and the impact of that threat. So let us see the classification of threat. Threats can be classified as natural threats, human error or failure, and then intentional threats. Natural threats. So natural threats are act of nature which can be unpredictable in terms of onset, duration, and impact. So they are also known as natural hazards. Examples of natural threats are earthquake, flood, and forest fires. Forces of nature are among the most dangerous threat because the area, geographical area which they impact is very large. They disrupt the individual lives as well as the information which is stored, and also prevents the transmission of information, because it might be possible that when a natural threat occurs, earthquake occurs, it is not just that a particular data center or a node goes down, it is that the entire network connecting that goes down or fails, and the data center may be completely isolated. Then organizations must implement controls to limit damage and prepare for the worst case scenario. For example, in cloud computing, data is replicated, and this replication is, for example, in cloud computing, usually the data is replicated by the cloud provider in another data center which is not in the same disaster zone. Next, human errors or failures. There is a difference between human errors or failures and intentional threats. Here, basically, this is due to the actions without malicious intent. So, causes include inexperience, improper training, and incorrect assumptions of the people involved in this kind of threat. So, employees' mistakes can easily lead to revelation of classified data, entry of erroneous data, accidental data deletion or modification, data storage in unprotected areas, and failure to protect information. Next is deliberate acts of espionage or trespass. That means to obtain the protected information. So in this, unauthorized people try to access the protected information. Now, if the information is protected or secret, it can be obtained via two ways. Either it can be obtained via competitive intelligence, which is legal. That is, that information can be asked through a proper channel, or it can be industrial espionage. That is illegal. That is the user will try to steal the information out. So, whenever an act of trespass occurs, controls let trespasser know that they are encroaching on the organization's cyberspace. That is, the firewall might send the message to the attackers that you are trespassing, and or this is not allowed. Uh, this is not the space where they should be right now. And what can hackers do? They can use their skills to bypass such controls which are protecting the sensitive information. So these are the deliberate acts. Deliberate act of theft. Electronic theft is a more complex evidence of crime, but it is not obvious. So, for example, if a physical object is stolen, then it is very easy to report that and quantify that. But to quantify the electronic theft is a very complex process. So, for example, a design has been stolen from some server or machine. Now, how to quantify that? The attacker or the user who has the malicious user who has stolen that design can slightly modify the design and claim that it's their own design. So it is very complex process. So in this, it is illegal. It refers to illegal taking of others' physical, electronic, or intellectual property. Privacy. So this leads to privacy and copyright infringement, abuse of rights, and denial of actions. Next, let us look at intentional threats. This is the activity done on purpose to compromise an IT system brought about by threat actors or groups. Deliberate software attacks. We have already discussed the software attacks. Uh, Deviation in service from providers, and this deviation in the service can be due to power issues or internet provider issue. For example, if the cloud provider sets up a data center in a location where power or electricity is an issue, or the internet connection is an issue, then it will not, then the cloud provider, even though it has all the infrastructures, will not be able to provide the promised service to the user. Then technology hardware failures, that is maybe the equipment fails. Technological software failures, there can be bugs, there can be code problems, there can be loopholes which are not yet recognized. Then there can be top technological obsolescence, that is antiquated or outdated technologies. So if a technology is outdated, then it is a threat because it can be compromised easily. Threat mitigation. So why should organizations do threat modeling? So why is it important? Because change in technology increases the threat rate on the network security. This is a established fact that as the new technologies are coming, there might be some loopholes in these which might be a soft spot for the attackers to attack. Cybercrime damage cost is estimated up to $6 trillion annually. Threats can come from outside or within the organization. Then attacks can cause system dysfunction entirely or may lead to leaking of sensitive information. Finally, to prevent the threat to exploit system vulnerabilities, one of the effective methods to mitigate threat is threat modeling. So all these four reasons are a big enough motivation for the organizations to do threat modeling. So threat modeling allows the creation of a generalization of a system. So if a system is generalized, then it can be analyzed more easily, and using the previous past knowledge, the loopholes can be tackled. Then identification of profiles of potential attackers, including their goals and methods adopted by them to attack. And it also helps the organization to identify a set of potential threats that may arise. So if an organization does the threat modeling, then they can identify the potential attackers and the threats that may arise. Also, with the generalized system, they can apply the previous methods to mitigate these threats. So, and then when the threat modeling should be done, it should be done in the development cycle, in the early cycle, so that the issues can be detected and resolved. What are the advantages of threat modeling? If used early, then it can prevent expensive fix, which may be required later on otherwise. Using threat modeling, one can take proactive decisions regarding security requirements that help to reduce the threat from start. Threat modeling can be particularly helpful in the area of cyber physical systems. Physical systems are like, so for example, we have these self-driven cars. So in these self-driven cars, there is a code, and these are obviously connected to the internet. So attackers can attack such kind of systems. They can put a bug in the code, or they can disrupt the network through which these self-driven cars are connected to the network. So in these kind of areas, threat modeling can be particularly helpful. What models or methods are available for threat modeling? There are 12 models which are available for threat modeling. We'll have a look at these models in the next lecture, and we'll do one of them in detail. Thank you.